Alright, hello. This is a video going over the answers for the CS 159 2022 Spring Exam 2. Let's get into it. Alright, so the first question. Which of the following is the output generated by the code segment shown here? So, as we see here, we have two variables that we're going to keep track of throughout the code. We have our total and we have our n. So this total, as we see, is initialized to just 0. And this n is initialized to this large number. So now we have this loop, this while loop that says while n is greater than our total, then we take these next two steps. So obviously in the first loop here, n is greater than total, so we go into the loop and we perform n modulus 100. And so basically all that's doing is that's just going to get the two last digits of n and put it into the total. So our total will now update to 59, because anytime we're modding by 100, we're just getting these last two digits here, 59. So we add 59, and then the total, or n here, down here, we're dividing by 10, so we get 1, 4, 6, 3, 5, and we just strip off the last digit because of integer division. And n is still greater than our total, so we'll just repeat this process. So now n mod 100, we get 35, 59 plus 35, that's 94. There we go. 94. And then again, we just take off the last digit, so we get 1463. 1463 is bigger than 94, so we got to do yet another loop. And once we do this next loop, we get 63 here as our modulus, and then if we add that plus 94, we get 157. And if we divide 1463 divided by 10, we get 146. And now n is no longer greater than our total, as we need by this condition here. So therefore, we break out of this loop, and then we go here and we print out the total. So if we track here, our total is 157. So therefore, we get question A, or answer A, sorry. All right, question number 2. We're just pretty much just repeating exactly what we did from the previous code. So if you want to look, just go back to question number 1. And you'll see as we track through here, we get an answer of n is 146. All right, question number 3. A new code segment here. So this one's asking us again what the output is generated by this code segment. So we just have one function here, just our main function. So we'll keep track of our variables like we always do. So our total and our n. So total is going to start out at 0. N is going to be 351. So then we enter this do while loop, and if you remember a do while loop, what that basically does is we run one iteration of the loop before we actually check the end condition. So it's always guaranteeing that we run one iteration of this loop. So this first if statement here, where we do n modulus 3 is equal to 0. So effectively what this is checking for is n divisible by 3. So is it divisible by 3? Because if it is divisible by 3, like 6 or 9, then the remainder is going to be 0, so the modulus 3 is going to be 0. Otherwise, if it's not divisible by 3, we do if n mod 2. So if n mod 2 is equal to 1, that means that it is going to be an odd number, right? As if n mod 2, because if we have 4, modulus it by 2, we get 0, which is not true, and that would be for an even number. So this checks is n odd. Otherwise, we do this update here. So our total starts at 0 and n is 351. So then we do 351 modulus 3, and when we divide by 3, that is a whole number. It's 117. So therefore, we enter into this body right here, and we do total plus equals n mod 10. So then our total becomes 1 now, and then we divide n by 10. So that gives us 35. So then we check 35. Is 35 divisible by 3? No, it is not, as the next one that's divisible by 3 is 36. And then we check is 35 mod 2, is that equal to 1 or 0? And in this case, this is an odd number, so that's going to be equal to 1. So this is odd. So that means we're going to jump into this loop here. We're going to add 1 to our total, and then we're going to subtract 1 from n. So then That's it for that loop. N is still greater than 34. I forgot to mention we needed to check that before, but n has been greater than 30 or greater than 0 this whole entire time. So 34 is greater than 0. So now we go back up to the top of the loop. We check is n divisible by 3. Is 34 divisible by 3? No, it is not, as 33 is divisible by 3. And then is 34 odd? No, it's not. So in this case, we have neither of them. So in that case, we're going down to this else bracket down here. So then we add 2 to our total to get 4. And then we subtract 2 from n to get 32. And then we head back up to the top to do another loop of this. So then we do 32 mod 3. That is not divisible by 3, so that is we're not gonna go into that loop. And then it is also not odd, so again, this is neither. So that means we're gonna increase our total to 6, and then we're gonna decrease n by 2, so we get 30. So now we go back up to the top, we do n mod 3 equal to 0, and we check is n mod 3 equal to 0? In this case it is, because 30 divided by 10 is equal to 3. So there's no remainder there. So then we add total, we add n mod 10. So we just add 0 to our total here. So then our total just becomes 6. And then we divide n by 10 to get 3 now. And then 3 is still greater than 0 at our condition there at the bottom, so we got to do yet another loop. And if we check this first divisible by 3, if we divide that by 3, that is obviously 1. So it is divisible by 3. So then we do total plus equals n mod 10. So total plus 3. So our total now becomes 9. And our n, we divide by 3, we now get 0. But now, in this case, n is no longer greater than 0, so we break out of our loop. And our total is equal to 9. Alright, question number 4. Which of the following is output generated? So this is the same code segment we used in the previous question, and if you go back to question number 3, after we trace it all through, you'll see that our n was in fact 0. So that is the correct answer for this question. Alright, question number 5, new code segment here. So in this question, it looks like we just have a singular main. So we want to track our n and our total through this code here. So n starts out uninitialized and total is 0. And then when we jump into this for loop here, so the first thing we do is we initialize n to be this large number. And then let's just look ahead at what this for loop is doing. So we check, is n greater than or equal to total? So in this case, our total is 0, right? So on that iteration, our total is 0. And then, so that's only on the first iteration. You'll notice that this should change on every iteration because we have this total in here. So contrary to the core standards, this is probably not the best use of a for loop. This would have better been used as a while loop. But they tend to do that on some of these exams sometimes. And then we do n divided by equal to 10 at the very end of it. So then we look inside of our for loop here, and we have this yummy looking ternary operator here. So basically what this is I always like to write these as if-else statements just to kind of help you see it better. It makes it a lot easier to make sense of. So what this is we do if n mod 100 is less than 50, then this is the condition if it's true. So we're doing total plus equals to negative n mod 100. So basically what that looks like, so this is the true because it's between the question mark and the colon, and then this expression will evaluate to true and it'll be equal to this value, and we'll be adding that to total. And then if it's not true, then we're at the back half of it there. Otherwise, our total plus equals n mod 100. So basically all this is doing is this mod 100 gets the last 2 digits of n, and then either we're subtracting total by it or we're adding total by it. And then we're doing that until our n, while n is greater than or equal to our total. So let's take a look through our first loop. So our first loop, n is 52741. So n mod 100 n mod 100, what is that going to be? That's going to be 41 here. 41 is less than 50, so it's true, so that means we need to subtract this 41 from the total, so we get negative 41. And then we need to do this condition up here and divide by 10, so then we get 5274. So then our n is still greater than or equal to our total, so we'll do another iteration here. If we do n mod 100, we get 74. 74 is less than 50, or I'm sorry, 74 is greater than 50, so our else statement will fire here. So we'll add 74 to total instead of subtract it. So negative 41 plus 74 is 33. And then again, we divide by 10 to get 527. 527 is still greater than 33, so another iteration here. Our last two digits are this 27. 27 is less than 50, so then we do total plus equals minus 27, which gives our total down to 6. Then we divide by 10 yet again. 52 is still greater than 6, so we will keep going through the loop. So then 52 mod 100 is just itself, it's 52, which is greater than 50, so this time we're going to add the value 52 to this. So that gives us 58, and then we divide by 10, so we're left with 2. And now you'll notice that this is no longer true, this condition that n is greater than total, that's no longer true. So we have to break out of this for loop, and then the next thing we do here is just print out this total. So that means our total for this question is 58, which is B, which is the correct answer. All right, so question number 6, it's just a continuation of the previous question, so if you go look at that, you'll see exactly what we got, and in that case, it looks like we got not the right answer. Oh, I'm sorry, this should not be a 2. That should be a 5, because we get rid of the 2. So, slight mistake there, but this, now it's the correct answer. We get n is equal to 5. All right, question number 7 here. We are dealing with a new code segment, and it looks like we're dealing with a lot of loops. So don't get too scared by the look of this problem here. We'll break it down so it makes a little bit more sense. So I mean, we can usually track our variables here, but in this case, if we take a look through this code here, so we see we're initializing this total to 0, and the only thing that happens among all these loops is every time the very innermost loop executes, we add 1 to our total. So effectively what this is doing is it's counting the number of times that we loop. So this for loop will iterate a certain number of times, and then on every single one of those iterations, this will iterate a certain number of times. Then on a certain number of these iterations, this will iterate a certain number of times, and then every time we add 1. So basically we have to figure out how many times is this loop, and that will be our total. And so that will be what we get printed out here at the very end. So just to kind of reiterate, we just need to determine number of loops. So let's go about doing that. So if we check out this outermost loop, we see that it's going to start with 1. Then we're going to add 2 to 3. Then we're going to add 2 to 5. Then we're going to add 2 to 7. And then we're going to add 2 and get 9. But 9 is not less than 9, so we don't actually iterate on this loop, as that's when we break out. And then on the inner loop, we start with y equals 1. And then y, we multiply it by 2 to get 2. And then we multiply it by 2, 4, then we get 8, 16, 32. But 32 is not less than 30, so we break out of that. And then the innermost loop, we start with this very large number. We get 5, 4, 5, 4, 5. Then we divide by 10 to get 5, 4, 5, 4. I'm going to move this over. Then we get 5, 4, 5, then 5, 4, 5, and then 5 divided by 10 is 0, but z is 0 is equal to 0, so we have to break out of the loop here. So if we count the number of loops here, this outermost one here, if we count, that's going to be 1, 2, 3, 4, so that'll be 4 loops. The innermost, or the second one, will be 1, 2, 3, 4, 5 loops. And so why aren't we counting this very last one? It's because that's when we break out of the loop. So we don't actually do an iteration of it, but we do check it. But the total is not going to get updated on that one because we never actually iterate through it. And then this innermost, we get 1, 2, 3, 4, 5. We have 5 loops as well. So whenever you're dealing with loops, if you're trying to figure out the total number of loops, so since we have this outer one and then we have one inside of it, basically on every single one of these 4s, we're also going to have a 5. So on the fourth iteration, so if we look at it like this, on the first iteration, we'll do 5 inner loops. Then on the second iteration, we'll do 5 inner loops. On the third, you guessed it, 5. Fourth, 5. So every single one of these is, we're going to do 5 loops. So you can look at this, and that's effectively just doing 4 times 5. That's the number of loops of the outer two most ones. And then we have one on the inside of that, so again, we have to even consider that as well. So basically, the number of loops when we have nested loops is just, you just multiply all of the number of times each one iterates together, and that gives you the total number of loops. So we do 4 times 5 times 5, well, that will give us 100. So therefore, our total is going to equal 100, since the total is effectively just counting the total number of loops. So that would be answer number C, which is the correct answer. So when you're facing a problem like this, you don't necessarily have to go through and count all 100 times it loops. Rather, it's good to kind of see that they're all nested and that the total is just the total number of loops. So then you can kind of use this quicker logic to figure out what the value is going to be. Okay, question number 8 here. So we're dealing with this same loop here, but this time it's asking us to print out what the sum is. And so the sum is just this x plus y plus z. So if we remember really quick, our this loop here is going to go from 1, then to 3, then to 5, then to 7, and then to 9. And then it breaks out on the 9. So that means that x, when we're all done, is going to be equal to 9. And then this next loop, we're going to start at 1, then we're going to 2, 4, 8, 16, 32. So we break out on 32 here. So y is going to have the value 32. And then this innermost one, well, we just see here that it breaks when it is equal to 0, because it cannot equal 0. So that means that z is just going to be equal to 0. So that will be the value of z. So then our total is just merely the sum of these 3 values. So we get 9 plus 32 plus 0, which is 41, which is our correct answer. So then if we move on to question number 9 here, we're dealing with a new piece of code, and it looks like we're dealing with our first user-defined function in this code here. Okay, so these ones can turn into a lot to track, but you just got to make sure you track the variables all the way through in both functions. So if we see here, we have our n, we have n at 5, 3, 6, 4, 2, and our total is 0. So then we jump into this do while loop, so we'll iterate through it the first time regardless. And so this n value gets passed directly here, and then this is n mod 2. So this is basically saying, is this odd? Because if modulus 2 is equal to 0, that means it's even, and so that'll be false. And if it's odd, then that'll be modulus 2 will be equal to 1, which means basically, is this even or odd? So then we pass these values into this make calculation function. So let's keep track. In our make calculation function, we get n, and then we get this start. And then we also get this result here. So we have to make sure we track all 3 of these throughout the function here. So in the very first one, when we pass it through, we get our n is 5, 3, 6, 4, 2. And then the second parameter which gets passed is this n mod 2. So in this case, the last digit's 2. When we mod by 2, that's just 0. So our start is equal to 0. So then what is this function down here doing exactly? So the first thing we do is we set result equal to start. So our result starts with 0. And we're saying while n mod 10 is greater than 0, so basically while the last digit is greater than 0 or while it's not 0, Then we enter this switch statement with our start value, and then do some different changes to it. So let's just jump right through. So the first check we have here is while 2 is 2 greater than 0, it is greater than 0. So then we do a switch on start, and the value of start is 0. So we go to this case 0 here. So we do result plus equal n mod 10. So our result, we just add to it the value 2. And then we break out of the switch. Make sure you check for breaks, otherwise it'll flow through. We break out, and then we subtract 1 from n. So then we get 5, 3, 6, 4, 1. So then we go back up to the top of our loop. We check, is this, so n mod 10 is 1, greater than 0. So we go back in. The switch on start remains 0. So we do the same case where we just add the last digit. So this becomes 3. And then we break out, and then we get n minus minus, so we get 5, 3, 6, 4, 1, or sorry, 0. We have to subtract 1. And then if we see here, this 0 is not greater than 0, so we break out of the while loop and we return this result. So this result gets returned back to where it was called, and it was called in main here at this make calculation function. So that means we're doing total plus equals what was returned. So we're adding 3 to total in main, since that's what gets returned by this make calculation function. And we add that to total, and then we move on to the next line in main, which is n divided by equal to 10, which is just 5, 3, 6, 4 due to integer division. And n is greater than 0, so we gotta do this all over again. So in our user-defined function here, if we make a new line to represent a new call, so we pass in 5, 3, 6, 4, and then 5, 3, 6, 4 modulus 2, well, that is an even number, so that means that it's going to pass in a 0 again. And then as we see in make calculation, we set result equal to start again, so result starts out at 0 here. So then we do the same thing, so while n mod 10 is greater than 0. So n mod 10 is going to be this last 4 here. So we do the switch on start, and start is always going to be 0. So we always, at least in this call, so we know we're going to be in here. So we do result plus equals n mod 10. So we add 4 to result, and then we break out, then subtract it by 1. And so we're basically just going to repeat this process until this last digit is 0. So if we do that really quick, we add 4, we get 7, and then we get 5, 3, 6, 2. Then we get 9, then we get 5, 3, 6, 1, then we get 10, and then 5, 3, 6, 0. Now this last digit is 0, so we break out of it and we send this 10 back up to main, back up here where it came from, and make calculation, and we add that 10 to our total, so we get 13 is our new total, and then we divide by 10, so we get 5, 3, 6. And then 5, 3, 6 is still greater than 0, so then we pass this back into the function. So now we're passing in 5, what is blue? 5, 3, 6. It is still an even number, so this is still 0. Result starts at 0. And again, we're doing the same thing. So basically, whenever start is 0, basically what we're doing is we take this last digit, add it to result, then subtract it until we get to 0. So on this iteration, we'll add 6, then we subtract n by 1, and then we take the last digit again, add it plus our result, then so on and so forth. We get 15, then we get 18, then we get 20, 21, and now finally it's equal to 0, so we break out of the loop there, and we send this back up to main. So in main we add 21 plus our total, so we get 34, and then we divide n by 10 again, so we get 53. 53 is still greater than 0, so we got to do yet another loop, and we're running out of space, so I'll move over here. So this is for our make calculation again. So our n this time is just 53. This time we have an odd number because 53 is odd. So our start is going to start at 1. So that means result starts at 1. So our behavior is going to be a little bit different this time, so we want to make sure we pay attention. So n mod 10 is going to be 3. So that's 3. But now in our switch statement here, we have switch start, but start is now 1. So we go down to 1 here, and we do result times equals n mod 10. So this time we're multiplying result by whatever value we had. So we multiply result by 3, then we break out of the switch here since it ends, and we subtract by 1. So then we get 52. So then same thing here, we get a 2, that's still greater than 0. Then we multiply result by 2, so now we get 6. Subtract by 1, we get 51. That's still just going to be 6, and then subtract by 1, 50. 0 is not greater than 0, so we'll go send that back up to main. So we'll send 6, so then we get 40 if we add it to total, and then we divide 53 by 10, and we get 5. And then that's still greater than 0, so we got to do one last loop here. So we call this function one last time. We pass in 5. 5 is an odd number, or yeah, it's an odd number. So 5. So that means start is going to be 1, and result's going to start with 1. So if you remember, anytime it starts with 1 like this, we take this 5, and then we multiply the result by 5, so we get 5. Then we subtract by 1, get 4. Then multiply by 4. Subtract, multiply by 3, subtract, multiply by 2, subtract, multiply by 1, which is the same thing. Now we're at 0, so now at 0 mod 10 is 0, greater than 0, no longer true, so then we break out of this, we return this result back up into main, so then we add that to our total, so now our total becomes 160, and we divide 5 by 10, which gives us 0. And so now 0 is no longer greater than 0. So that means we're finally done with the problem, and we print out our total, which is 160. So this is a pretty involved problem. You just got to make sure you really track all of the stuff that's going on and kind of see the pattern maybe a little bit in the make calculation function to help speed up that process just a little bit. Okay, question number 10. Which of the following statements regarding the program is true? So the first one, we'll just go through each one. A states the logic in the program above includes nested repetition. Well, let's see here. So we have our first block of repetition right here, and then there's also some repetition down here. So this is a question I see come up a lot on exams. So make sure you kind of understand why this is the case. So we have repetition here. And it may not look like we have nested repetition, but we actually do, because we call this make calculation function, and as we said, in this make calculation function we have this while loop inside of it. So effectively we're doing a while loop inside of this do while loop, so therefore we have nested repetition, because we have a repetition structure inside of another repetition structure. So if you tracked on the last problem on number 9, you notice that we had the outer loop, and then every iteration of that we had to go into the user-defined function, and we had to do the inner loop where every time we're looping through until n mod 10 is greater than 0, or while it's greater than 0 rather. So that means this is true, so A is true, but we'll go through the other ones just to see why they're false, in case they tripped you up at all. So B, the process being implemented using the do while is event control. So this one is kind of a tricky question, because it kind of seems like it's being event controlled because it says n is greater than 0. But how I kind of think about it is that it's technically counter controlled, because you can think of a counter controlled process as a process where you know how many iterations is going to happen before it ends. So in this case, we take 5, 3, 6, 4, 2, and we just keep dividing by 10 until it gets to 0. So we know that it's going to loop, I think, 5 different times. So we know after the 5th loop, then it's going to stop looping. So technically, that makes it a counter-controlled process instead of more of an event-controlled. An event-controlled is more something that could happen a little bit more randomly, so to speak. So like say, something suddenly becomes true because something else made it true. That's more of a event-controlled process. So it is a tricky question. I kind of got tripped up myself. And then answer option C here. The number of times a while loops iterates is equal to the number of digits in the integer n, which is not entirely true, as the while loop iterates until our, the while loop, sorry. Okay, I got tripped out. So the while loop, so that's referring to this down here. And that's more just iterating until that last digit, the n mod 10, we're iterating until that is equal to 0. And that's not necessarily the number of digits in it. The do while loop is iterating the number of times that the number of digits in n, but the while loop is not. So make sure you just kind of read the semantics of the question there as they're trying to trip you up. All right, question number 11, a new question here. Now we're doing some logical structures ones. And so big thing on these is draw your parentheses for your order of operations so that you don't get tripped up by it. So if you look at the table, which should be at the end of the exams, we know and comes before or. So we can draw, we'll just cover this one up. So this x plus plus and plus plus y will happen before we do the or, so make sure you see that. And then we have another and in the second one here, so this and will come before the or. Try to ignore the parentheses. It's hard to write inside the parentheses a little bit, but you get the general idea there, hopefully. And then this last one here does not have any precedence too much that we have to consider that or kind of help ourselves out with. So if we kind of track our variables here, we have x, y, and z, and so we're going to initialize those all to be 0 to start. So let's jump into our first if statement. So we do if x plus plus, so that's just going to be 0 because the plus plus means it happens after the fact. So if that's true, so x plus plus is 0, 0 is false, and no matter what, this and statement will never be true. So what that means is that this plus plus y is never going to happen because we're just going to short circuit and we're never going to execute on that plus plus y. So we can basically just ignore that's going to happen because no matter what the value of y is, it's impossible for this and statement to be true. So we basically skip through it and then we look at z instead. So z plus plus, we're just going to have a value of 0. And so that is not true. 0 is not true. So then we will not execute here, and we got to go down to the next if statement. Before we go to the next else if, we need to make sure we increment what we need to increment. So this 0, this x we looked at, so that's going to increment to 1, and the z we also looked at, which will increment to 1. Please note that we did not look at this plus plus y because it's short-circuited here. That's why I crossed it out to kind of help ourselves out. So y does not increase, so be careful. That's kind of the whole purpose of this question, is to see if you understand how that works exactly. So on this else if, the first thing that happens is this minus minus y. So minus minus means it happens before it gets executed, so we subtract 1. So y now becomes negative 1. So this value is negative 1. And negative 1 is technically a true value because the only value that's false is 0. So we are going to go inside of this else if statement here. And so we're going to set z equal to y is greater than x. And is y greater than x? Is negative 1 greater than 1? No, it is not. So that means z is going to be 0. And then this never happens, and this never happens since we executed inside of here. So now we just print off our x value, and our x value is just going to be 1, which is the correct answer. So then question number 12, if you just see the previous question here, question number 11, you'll see that we found y is negative 1 and z is 0. So just look at how I did that. So that is a correct answer for this one. Okay, question number 13. Which of the following logical operators has one of its two operands evaluated, the operator short-circuited in the code segment above? So basically we just have to see which one's short-circuit. So let's go back to question number 11, where we actually trace through this code. And you'll see here, so if we write our question, let's write our line numbers just for reference. 9, that's 13, and then that's 17. So this question here is asking us, is it the or on line 9, is it the and on line 9, or is it the and on line 17? So the or on line 9 is here, the and is here, and then the other and is here. So if you see here this x, I wrote this to help myself because I had a feeling there would be a question like this in the future. We see this x, I set it short-circuited, right, because this is a 0, so this will never execute. So that means this and is the one that short-circuits. So the and on line 9. So that means B is going to be our correct answer for this one. Okay, which of the following statements regarding the usage of the switch construct is false? A, each switch case label is the keyword case followed by a constant expression. So this is in fact true, as this is basically just exactly describing what a switch and switch statement looks like. And the keyword here is constant expression. So talked about this in the course, but when we have a case here, it has to be a constant expression. It can't be some variable or something that might change on every iteration. It has to be something that evaluates to be a set value every single time. So that does make this true, so that means that A is not the correct answer. B, each case label represents an integral value that is possible result of the control expression. So this is also true, so it's not the correct answer. And when it says, you might ask, what is an integral value? Well, that is just an integer value, basically. So there's no decimal or float, however you want to think about it. So it has to be an integer value, no floats. So this is true of cases. Represents, yeah. So when it says the control expression too, what that is if we look at switch x here, for example, this x right here, that's the control expression. So that's the control expression. So this has to evaluate to be an integer value. It cannot be a float value, it cannot be a decimal value. It has to be an integer value, so whether that be an integer or a char, or a long, it has to be an integral value, as the switch case does not work with float values. And then C, no case label may consist of an expression with multiple mathematical operators. This is actually false, so this is the correct answer. So this is a prime example. So this one right here is legal, the 0 plus 1, because it always evaluates to 1. It never changes. We know that's always going to be 1. So maybe you could also have a case 5 plus 3 mod 2 or something like that. But we always know that expression there is going to evaluate to 6. So we can still have multiple mathematical operators. It just has to evaluate to a constant expression. So that means C is going to be our correct answer. All right, question number 15 here. Question number 15, which of the following is the first line of output generated by the code segment? Okay, so if we look through here really quick, we call this count direct function, this count direct. Oh boy, we have a count direct inside a count direct. So what is this going to be? This is going to be recursion, which can be kind of scary. It's definitely a strange concept to understand at first. So let's just go and jump in and kind of explain how this is going to be working. So the first thing that happens, we set this x equal to 10, and then we call this count direct function. So anytime we're dealing with recursion, I always like to keep track of what we call and where we are on the timeline, basically. So we call count direct is equal to 10. So then inside this count direct function down here, we have this n value. So we pass it in as 10. And then we check, is n greater than 0? It is greater than 0. So then we subtract 1 from n after the fact, right? We do n. And then here's the important part. We print it before we go into this recursion. So right now, right away, we go and we print this. So this gets printed. So we print it, and then this n value then gets passed down into another call of this count direct function. So we call count direct yet again, and this time it has a value of 9. So if we track through it again, we have 9, and then we check, is that greater than 0? It is greater than 0, so 9 is greater than 0, so we subtract. This happens afterwards, so then it gets down to 8, and then we print that. We print out 8. So now we have printed out 9, and then we have printed out an 8. And then we call count direct yet again. Count direct this time of 8. So we could go all the way down, until it stops. But we know exactly when this is going to stop, right? Because as soon as n is equal to 0, then we're no longer going to do it. So basically, once this, we don't know exactly what that would look like, but if n is equal to 0, then we're going to break out of here. So if we weren't to break out, that would have gone to -1, and then we would have printed a -1. But since we broke out before that, we know that all of the values from 9 until 0 here were printed out. So that'd be 9, 8, 7, 6, 5, blah, 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 2, 1, 0. So we know that that's all the values are going to be printed out, and then once this is no longer true, we finally return this n value back up the chain. And in this instance, we don't care too much. I guess we kind of care about. So basically, in this case, we do n minus minus greater than 0, so we return a -1, right? Because that'll happen. So then it'll return -1, then it'll return a 0, 1. So on and so forth, all the way back up the chain. But in this case, we're just interested in what it actually printed out. So we can see here that it printed out B, because we went from 9 all the way down to 0. So an interesting thing to think about too is what would have happened if the print was on this stuff. What if the print was here? What if we printed after the fact? So then we would have gone all the way down to 0, and then we would have came all the way back up. So instead, we would have pretty much had the reverse order. We would have had 0, 1, 2, 3, 4, 5. Maybe not the quite right numbers on the ends of it, but it would be printing it in the reverse order. Since we printed it before we went down it, that's what we get. So, I mean, you can track through all of them. You can see all of the calls, but if you kind of see this pattern, and then the key with recursion is you figure out the base case. So we figure out where we're going to break out. So we're going to break out when n is equal to 0. So that's how we know what the very last call of the recursive statements are going to be, and then that's how we know when we go back up the chain. So we know that B is going to be our correct answer. So as we kind of mentioned, our very last call to count direct, because in this case it's asking us what this result is, so what gets returned by this. So our last call to count direct will be 0, right? So as we said here, 0 is not greater than 0, so this will not execute, so we won't call this again. But what will happen is we will subtract by 1, so n will go from 0 to -1. So then we return this -1 back up the chain. So this -1 gets returned. But all that happens between here and the next return is we just store it and then we pass it back up. So we get -1, then it goes -1, -1, -1. It does get passed all the way back up the chain, all the way back up until our original call, which was count direct 10. So once we get all the way up here, we return -1, and then this returns -1 back to the main function. So basically we just return this -1 all the way through all the functions, and so we get A. I think I might have misspoken the previous question. I might have said that it was returning different numbers back up the chain, but no, it's returning this -1 all the way back up the chain, since we are not adjusting n at all between where it gets returned and where we return it to the previous function call. So hopefully that kind of makes a little bit of sense. Okay, so question number 17 is another true-false type of question. So it's asking us, which of the following statements regarding for loops is false according to core standards? So that's an important note here, core standards. So these may be legal, but not in the CS159 world. So make sure we keep in mind of that. So the first thing says a for loop should only be used with counter-controlled processes. This is something that you really need to know. Make sure you know while loop or do while. That is for event controlled. For loop is for counter controlled. They always ask at least a few questions on every exam, the difference between if a while loop is event controlled or if a for loop is counter controlled, so make sure you know the difference. Make sure you know that. So in this case, a for loop should be used for counter controlled processes, so this is in fact true, so it's not the right answer. Then B, the loop control variable can be declared and initialized in the first expression of a for loop. So what this is referring to is our loop control variable. So this is what it's telling us is we could initialize it. We could declare it. This is the declaration. Then we can initialize it. That's the initialization in the same one. So we'll just add some random variables here, or some the rest of this for loop. So it's asking, is this logic here, is this legal? And this is legal C logic, but in the CS159 world, they do not want you doing this. So this is not allowed. Instead, what you're supposed to do, the correct way to do this is you declare your loop control variable. So it's the loop control variable because it's the one we use to actually, control the loop. Sorry, not the best explanation there, but they want you to declare outside of the loop, and then you can do your for i's. You set it there, and then you do the rest of it just like normal. So this is the correct form. This is the incorrect form. So that makes this B1 false, which makes it the correct answer because we are not allowed to declare and initialize the loop control variable in the first expression of a for loop in this course. And then C, we'll just cover our basis here. Make use of all three expressions when implementing a for loop in your program. This is true, so all three expressions, what this is referring to, that's the first one, that's the second one, that's the third one. Anytime you write a loop in this course, and honestly, anytime you write a for loop ever, you should make sure you have all three of these statements or expressions or whatever you want to call them in your for loop, as that is certainly the best practice for it. So, and B is in fact our correct answer. Okay, 18. Given this logical expression, which of the following logical expressions is one possible complement of a logical expression above? Okay, so anytime you see these logical complement ones, I like to refer to something called De Morgan's law. This is something that's taught in like sophomore level ECE courses. But I think it's very helpful for these types of questions because it's basically the same exact purpose and it's not too complicated of a concept. So kind of what De Morgan's law is it's useful for finding what the complement of something is. So first off, let's just use our order of precedence. Let's make sure we do the right thing first. So we do and before or. So this is what our parentheses would look like for this problem here. So if we want to find the logical complement, anytime it asks you which of these is a possible logical complement, I like to actually generate all of the logical complements, like potential logical complements, so then I can compare them. I find that to be one of the fastest ways to do it. And so that can be done using this De Morgan's law. I recommend looking it up, maybe learn a little bit more about it, or even watching some of the older exam videos for exam 2, as I think I have explained it before in the past. Anyways, so when we're finding this complement, we take the complement of this entire expression. So I'm going to rewrite this entire expression here with the parentheses that I gave it. And so this De Morgan's law is relatively simple. Basically what it says is we can factor this into or expand this not throughout the entire expression. So basically we have the not affect every single aspect of the thing, and basically it just reverses exactly what it did before. And an important thing to note is that we have to make sure we keep the same order of operations. So the first thing we do is we just not this x less than a. And so one of the more important things of De Morgan's law is that anytime we have a not, we flip all of our ors to ands, and we flip all of our ands to ors. So that's a very important thing. So this or is going to turn into an and then we're just going to, similar to how you would do math, we're just going to put this complement out on the outside of this entire thing, so we haven't actually touched the inside of this yet. So then we need to find the logical complement of x less than a. So what is the exact opposite of less than a? Well, that would be greater than or equal to a. So that would turn into greater than or equal to a. We already flipped this around. So then we need to send that through the rest of that. So basically what that would look like is we have x is greater than b, and then now we can apply it to this and. So we get or, and then we get not x less than or equal to c. So then we have one more. It looks like we can expand the not through one last time here. So if we do one more iteration of this, we get what is opposite of x greater than b? Well, oh yeah, one important thing, we need to make sure we keep the parentheses here. The opposite of x greater than b is x less than or equal to b. We already did the or there, and then the opposite of x not equal to c is x equal to c. So as you see here, we expanded that exclamation mark all the way through, and so we basically just used De Morgan's law, where we every single thing inside of here we complemented it, including the ands and the or. So every single statement got complemented, but if you notice here, our order of operations stay the same. So we have to make sure we explicitly keep these, because if we didn't, then that means this and would now take precedence, but we need to make sure we keep the original order of operations. So that's a very important thing to keep in mind, as you'll see here, because some of these answers try to trick you into thinking that you did it improperly. And by and large, this very first one happens to be doing that. So if you see here, all of these statements are the exact same. We have x greater than or equal to a, x less than or equal to b, x equal to c, and we even have the same ands and ors. However, this is not the same logical complement, as we have slightly different order of operations. This one doesn't explicitly define it, but since we have the and first, it's going to look like this. And so that is actually slightly different than what the one we generated, as we do this in a slightly different order. So that means that this is not a correct answer. And then if we look on to this next one, so this next one, it looks awfully similar to this over here, right? Because we have the same, all of these same things through here. But if you notice, they didn't quite do De Morgan's law entirely correct, as they have an or right here, but we know, since we've sent that through, that not made this or an and. So this or is now an and, whereas here it shows it still as an or. So that is not quite correct. And then finally, we have one that looks very similar yet again, but again we are not in quite the correct order, as we have these parentheses around the left side instead of around the right side here. So again, that's not quite the correct one. And so the De Morgan's law, I recommend you look it up, maybe try and spend a little bit more time with this example, try and figure out how it works, because I think it's a really powerful way to do it. I wish I would have known how to use it when I took the course. But if that's not really your cup of tea, you can also verify, you can basically just verify all combos of x, a, b, and c. So these can all either be 0 or 1. So if you check all of these, then anything that's a complement, if it's a complement, then it should return opposite. So if the original expression returns a 1, then the complement should return a 0. And it should do that for every single 0 and 1 for every single x, a, b, and c. So it's a lot easier to figure out if something is not a logical complement, because you just have to find one instance where they're not the same. Whereas to say they are the same, you have to prove that every single one of them is the exact same. So that is another way, but it can be a little bit more time consuming, which is why I recommend the De Morgan's law approach. All right, moving on now to question 19. So question 19 here is asking us, which of the following statements regarding selection is true? So if you remember selection, that's like if else, that's case switch or switch case. So which of these is true? The first one is conditional expressions cannot be nested. This is false. It's false, as what it means by nested is if we have if some expression here, can we have another one inside of it like this, and maybe even more, which of course we do know is true, as you're allowed to nest them as many times as you want. You might want to be careful, but you are allowed to nest them, so that is false. B, the dangling else logical error can be corrected by indenting the if and else statement to the same number of spaces. So what is the dangling else logical error, you might ask? So there's lots of good resources online about this, but I'll do a quick explanation. So say we are lazy and we don't want to use any brackets, which is perfectly fine in the C language, and we have these expressions here. And the way I indented this might make it seem like this else statement here is linked to this if statement up here. But what is actually happening is C looks for the previous if statement. So actually these two are linked together instead. So it's kind of like looking at it like this in a way. So what you're trying to get instead by doing it like this, what the original goal was something more like this. If we're more explicit with our brackets, it would look like this, right? So now we know, this is expression 1. So now we know for sure that these are linked together because we explicitly defined what the body of this if statement is. Whereas before, as we never had brackets, so we never explicitly defined it. So this question here is saying it can be corrected by indenting the if-else the same number of spaces. So keyword there, indenting. Anytime we do any sort of indenting in C, that makes no difference on the actual execution of the program. Where it does make a difference is Python. If you've ever used Python, that would actually make the difference. But we are not using Python. So that actually does not fix our logical error, as instead what we want to do is use brackets, like I mentioned before. So brackets are the solution to the dangling else problem. So this is, in fact, false. C, the condition of an if-else statement must be enclosed in parentheses. So what this is saying is we have to do this, not like that. This is true. We do have, in C, you do have to enclose an if-else, or an if the condition in an if statement has to be in parentheses, has to look like this. Again, this is something legal in Python, but we are using C, not Python, so you have to make sure you use parentheses. All right, question number 20. Which of the following statements regarding random number generation is false? First one states, each call to the rand function returns the next integer in the series of random numbers. So what does this mean? So a call to the rand function just looks like this. Rand, what does this return? This just returns, well, a random number. And every time you call rand, it's going to return you a new random number in whatever series of random numbers. So this is true, so it's not our correct answer. So if you got tripped up by this, you might be thinking of the srand function, which we look at here, B. The srand function must be only called once for each desired series of random numbers. This is true, because what the srand does is it sets our seed value. So we can think of our seed. So say we do srand 300 here, right? So then our seed value is 300. So then basically what rand does, if we do rand, just performs a bunch of random operations that are the same, so to speak, to generate this new random number. So then we get maybe 52, maybe we do call rand again, then it gets like 34, 21, so on and so forth. But if we generate all these random numbers and then we seed it, we call this srand 300 again, and we call it rand, well, this is just going to generate the same sequence of random numbers because we started from the same point. So that's kind of how srand works. So anytime we're trying to generate a series of random numbers, you should only call srand once. Usually you should just call it in your main function after you get your seed value, and then you can use that for random generation for the rest of the problem. And then C, a call to the srand function includes the seed value as a parameter. I have an example of srand right here, and the only value that gets passed in is the seed value. You need to include that. So this is true. So that means our answer, very excitingly, is none of the above, or D for 20. All right, question number 21. Which of the following will generate a random number in the range from x to y inclusive, where both variables are positive and y is strictly greater than x? So we're inclusive on both sides and y is greater than x. So what are we trying to do? We're basically just trying to generate from x to y inclusive on both sides, which is indicated by those brackets there. So let's look here. If we look at A, we do rand mod y less than x. So how I want to go about this, I'm just going to set x and y to be two values, and we see what range we get generated inside of. So say we set x to be 1 and y to be 3. We'll avoid 0 to avoid some edge cases. And so if we set that to be true, then A is going to turn into, well, we're going to have this rand, and then we're going to do mod, y minus x. So we'll do 3 minus 1, so that's going to be 2. And this modulus will happen first, so we'll have parentheses around it, and then we'll add 1 to it. So this rand mod 2, we can never generate a 2 with a modulus, right? Because if you do 1 mod 2, that gives you a 1. If you do 2 mod 2, which might generate a 2, well, that's just going to be a 0, right? Because 2 divided by 2, it's impossible to have a remainder equal to what you're dividing by, because then it's actually divisible by that number, right? So in this case, we're generating from 1 to 2 here. We are generating from 0 to 1. We're not generating 2 at all. And then once we add 1 to both of these bounds, then we're going to be generating from 1 to 2. And what are we looking to be generating from? We want to be generating from 1 to 3. So we know that that is not correct, as we're not generating to the right bounds. So A is incorrect. B. Let's look here. So now we're doing rand again. And we're modding by y minus x, which is 2. But now we add 1. So that gives us 3, right? And then again, we add by x, which is 1. So this time, this modulus 3, well, that's going to generate between 0 and 2, right? And then if we add 1 to both of those bounds, we're going to get 1 to 3. Well, that just so happens to be exactly what we're looking for. So that is likely our correct answer. But we will check C just to be safe. So we do rand modulus y minus x, which as we discussed is just 2. And then after we do the modulus, right, because order of operations, we add x plus 1. So we can just add those together now. X plus 1 is 2. So again, this will just generate between 0 and 1. We add 2 to it, so now we're just going to be generating between 2 and 3. So that is incorrect. So we know that C is also incorrect, which means B is in fact our correct answer. So I have seen a few of these problems before. This is one of my favorite approaches to do it, is just pick 2 numbers to be your bounds. Usually don't pick something that is 0, as that can generate some problems. Pick 2 integer values, positive values, and then see what ranges it actually generates in between, and then find the right one. So that is our answer. Moving on to question number 22. Which of the following statements regarding repetition is false? A, the initialization of the loop control variable must take place outside the body of a pretest loop. Okay, first off, what is a pretest loop? A pretest loop is something like a for or a while loop. Basically, we test condition before the first loop. Whereas a post-test loop is, well, the exact opposite. We this is more like a do-while loop, where we run one loop, then check the condition. So that's the difference between pre and a post-test loop, in case you were not quite aware. So for a while loop is because, in a for loop, we have like our I less than n or something. In our while loop, we have like x greater than 0. Whereas do, while, we don't check it till the end here, right? This gets checked after the iteration of the body here. So the initialization of the loop control variable must take outside the body of a pre-test loop. So this is in fact true, as since we have to test before we get to the body of the loop, we can't initialize the value of that value we're going to be testing. So say like here, say we don't initialize I until inside the for loop. Well, that's going to cause problems because this I is going to be uninitialized the very first time we look through it. So we do need to initialize it. We need to initialize it. Well, I guess in a for loop, it would get initialized right here. It would be I equals 0, something like that. So that would cause problems. So that's why this is in fact true, so it's not correct. And then B, the number of times that the loop control expression is evaluated is one more than the number of times in a post-test loop. I presume number of times. Okay, sorry. This is false. This would be true for a pre-test loop, right? Because we evaluate, so in a pre-test loop, so say we have some while loop here. So we will keep iterating, and once this becomes true, we test it one more time. So for the fourth test in this case, then we break out. So we'd have 4 tests, but we'd have 3 loops, right? Because we have to test it one more time before we break out. But in a post-test loop, since we loop once before we start actually checking, then we're actually just going to have the same number of loops as we do checks, I believe. So we do not look at this loop control expression one extra time in a post-test loop. Since it happens, we check it at the end of the loop as opposed to the beginning of the loop. So hopefully that makes some sense. And then C, it is possible for the update of the loop control variable to be part of the loop control expression in a pre-test loop. So the update of the loop control expression to be part of it. So this is a very odd question, but basically what this is saying is something to the effect of, say we had a while loop, and then we have x, and we do x plus plus, maybe like less than 5, something like that. So what this is saying is that, is this allowed? Can we do something like this? Because what we're doing is we're allowing the update of the loop control variable to be part of the loop control expression, right? This is perfectly legal since we have to initialize x up here anyways. So this is something that would be allowed, so that would make this true, which would make B the correct answer. Alrighty, moving on to question number 23. Which of the following may be an indication that the incorrect looping construct was selected for a repetitive process? Okay. A, identical logic found both inside and outside of the body of the loop. That is definitely an indication that we chose the wrong one. We never want identical logic if we can avoid it. So if you do have identical logic, you can avoid it using a different loop control looping construct, then you should use a different looping construct, as you do not want to duplicate your logic ever. B, so one thing to note here, this is like one of the first times I've ever seen this. There's none of the above on D. Instead, we have both A and B. So we need to keep that in mind looking at our answers here. B, the loop control variable is initialized to a value that guarantees at least one iteration. So not gonna lie, this one stumped me for a little bit. It's a very weird question, and it is in fact an indication that we have the incorrect looping construct. As I think I could be wrong with my conclusion, but I think it basically is we don't necessarily always want to loop if there's a way to avoid looping that is preferred. So basically, say right now we are using a while loop while x is greater than like 1 or something. Then we do all this stuff. Say we don't know exactly what x is going to look like beforehand, but say x is equal to 1. So then in this case, we won't actually do any looping, so we'll avoid looping at all. But say we had a do while loop, right? We had a do while with the same exact logic. Then basically we would be doing this extra iteration where we don't actually need to be doing it. So that'd be an extra iteration. Although this example is not great because it's talking about the loop control variable is initialized to a value. Yeah, I don't know. This is a weird one. I'm not. It kind of trips me up a little bit. But basically, like I kind of said, I think this is what this is referring to is that we're guaranteeing one iteration, and we should never say that we're guaranteeing an iteration. As if we don't want to loop, then we shouldn't have to loop. So I think that's kind of what they're going for. As B is a correct answer because it's not. It shows that we use the wrong looping construct. So this example might be kind of an indication of that, but I'm not entirely sure, to be honest. C, multiple logical operators are part of the loop control expression. That's fine. That's not an indication. What this is saying is, like, can we do while x is greater than 0 and y is less than 0? That's perfectly fine. I don't see why that would be an incorrect thing to do at all. And you certainly wouldn't want to be using a for loop for that anyway, so you probably chose the right thing to begin with. So that makes D, both A and B, kind of a crazy one, to be the correct answer. 24, we're finally getting back to tracing some code. Everyone's favorite. So let's look at, looks like we're going through some UDFs here, some user-defined functions. So we have this grade, then we just pass 84 into getGrade. So let's see, in getGrade we have the score. So the first thing that gets passed is 84. So our score starts out as 84. And then we have this pass, which is just -1. So then if we do a switch on this, so we do score plus 7. So 84 plus 7 is 91. And then we divide by 10. So that's going to be an integer division, right? Remember, switch cases have to be integral values. So what is that going to be equal to? Well, that's just going to be 9. So if we look into here, this is going to be 9 right here. So we set pass equal to 1. Then we break. So then we break out of the switch and we return some value here. So we return a -1 plus 1, which is just those the -1 and +1s cancel out, so that's just going to return an A. So back up in our main, we return an A, and then we print out grade 1 A right there. And then now we go to the next line. So we know for a fact that B and C cannot be correct, right? Because we print out B first. So now we have passed in a score of 68, and our pass is going to start out at -1 again. So we do 68 plus 7, which is 75. Do 75 divided by 10, which is integer division, which is just 7. So now we look at 7 here. So we set pass equal to 3, and then switch case is over, so then we break out of it. Then we do A -1 plus 3, so we get A plus 2. And this may look a little weird. You're like, what in the world is going on here? How are we adding a character and an integer? And if you remember, every character is represented in memory as a number. So this A, although it looks like a character, is actually just a number in memory. And so if we add 2 to it, so you could go look at your ASCII chart. I don't know exactly what A is, but you look at the value of A, you add 2 to that value, then you get what is being returned, because this is returning a char. But basically the ASCII chart, since these are all capital letters, A, the one after that's going to be capital B, then the one after that's going to be capital C. So we're just going to return a capital C here. So capital C gets returned back up to main. So that means the second thing, grade 2, prints out a capital C, which is A, which is our correct answer. All right, question number 25 now. Which of the following is the output generated by the code segment now that the break statements in the switch are removed? Oh boy, so if we look here, before we had these breaks right here and right here. Now they're gone, right? We no longer have them. So how is that going to change what we get? So let's track through it. Let's see what happens. That's not called grade. This is called score and pass. So remember, first thing we pass in is an 84. And then pass starts out at -1. So then we do 91 divided by 10. That equals 9 again. So now we go to here. We start at 9. But if you look here, oh no, we have no breaks. So now we go to 1. Then we go to 2. And then finally we go to 3. And then we finally break out because they never just use a break statement. So that's going to be 3. So basically anytime it's a 10, 9, 8, or a 7, it's going to return a value of 3. And if you remember before, that's just going to be A plus 2, which is a C. So this first one is just going to return a value of C. So we know for a fact that that cannot be right. And then let's look at it again. We pass in a 68. We initialize this to -1. 75 divided by 10 is equal to 7. So we start here. pass is equal to 3, then we break out right away. We do the same, A plus 2 equals C. So then we return a C again. So both of these should be C's, which is what answer option number C looks like. So a lot of C's on this question, but that's our correct answer. So just be careful. Since we didn't have our break statements here, that's why it pretty much any time it's just always pass is always going to be set equal to 3. So yeah. All right, question number 26, our first array question here on a new code segment. Okay, so first thing, anytime you see an array, and especially when it gets initialized by this statement here, I always check size and then check the number of elements we have. So there's 1, 2, so I order their indexes, but we have 7 elements here and we have 7 elements, so none of them got initialized to 0. So we know that we have 93, then we have 90, then we have 84, then we have 72, 63, 72, 38. And then if we order the indexes, we have all of these. Okay, and then what do we do now? We set our Y and our I's and our Z. I guess Z comes second here. Z, I, lots of little variables here. We have 0, 0, and then this I will become a 0 as well. Okay, so then let's take a look through what we're doing here. So one thing to keep in mind really quick, we're just printing out Y. And so to focus right away, I'm just going to ignore this and I can address it in the next problem as we care about that in the next one. So we see we're basically looping from the front of the array to the back of the array, right? So we need to keep that in mind. And so we're just starting at the very front index, going to this last index. And so what are we doing on every single one of those iterations? Well, we're doing this ternary operator, which is just checking if xi is less than xy, then we set y equal to I. Otherwise, we set y equal to y, which is already happening. So what is this doing exactly? Basically, it says anytime x of y is greater than x of I, we set y equal to I. So we're basically just finding the largest value here, right? Because we start at the front of the list. Both I and y are pointing at the front of the list. And then we check this next value with I. We see is 90, is it less than or is it greater than 93? And in this case, it is less than, right? So 90, or I'm sorry, we're not finding the max, or the largest. We're finding the smallest here, right? Because this is saying if this value is less than the current value which we have. So in this case, when we look at I, we say, is 90 less than 93? Why, yes it is. So then we move our y up to here, and then we move our I now up to this next one. So then we say, is 84, is it less than 90? Yep. So our y comes up here. Then we increase this again. Is 72 less than 84? Yep. So we move our y, and then we move our I. Is 63? Yep. So then we move both of them again. Then we move this I. Is 72 less than 63? No, it is not. So this time we do not update our y. Instead, we just update I. And so now we're looking at just 38. We say, is 38 less than 63? Why, yes, it is. So our y is now pointing at this value. So our y, which is just getting set to the index here, right? That's just going to be 6. So our y is going to have a value of 6, which is B, which is our correct answer. So I didn't really necessarily trace through the code super well exactly. I more kind of figured out what it was looking at and what it was trying to do, as that helps you understand the question better and it helps you figure out how to do it faster. So in this case, I just noticed this y basically is storing our min value, and it's the min value index, so the index of the minimum value, and then we check every single value in the array and see if it's smaller than that. And if it is, then we reset it as that is our new minimum. And so if you figure that out right away, you could easily just look, oh, where's the minimum value? It's at index 6, so that means we're going to return a 6. So that's how you do this problem. So question number 27, we're looking at the same code segment, but now we're interested in z. So this time we can ignore that y statement there. So what are we doing now? So if we write this ternary operator as an if statement to better see. So size, so that would just be 7 minus I minus 1. If that is greater than z, then we set z equal to x at 7 minus I minus 1. Otherwise z remains z. But that's trivial, so we don't really need to conclude that, as it's not super important to exactly what we're doing. So this is doing something very similar to what we were just talking about before. So if we track through so this is just going to be 6 minus I, right? And we're going from 0 to 6. So we're going from 0 to 6. So basically, when we do 6 minus I, we're going to start at 6, right? Because 6 minus 0 is 6. Then we increment I to 1. So now we go to 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4, 6 minus 5, and then 6 minus 6. So we're basically just iterating through this array backwards. So we're starting at the back here, and then we're making our way this way. But now we're just checking, is the current value, is it greater than z, right? So what does z get initialized to? Z is 0 initially. So then we check here. Is 38 greater than 0? Yep. So we set that to 38. Is 72 greater than 38? Yep. Is 63 greater than 72? Nope. So then we 72 greater than 72? Nope. It's 84. Yep. How about 90? Yep. 93? Yep. And then we end. So basically this is just finding the maximum value in our list, but it tries to trip you up because we're basically just iterating backwards through the array based on this logic here. So our answer is Z, 93. And yeah. All right, question number 28 here. Going back to our smaller questions. Which of the following for loops will correctly iterate over every element in an array of size 5? Okay, so let's look at this first one here. We're going from 1 to less than 5. So our values are going to be 1, 2, 3, 4, and then 5, but that's not less than 5, so we don't actually use that value. An array of size 5 is going to have indexes 0, 1, 2, 3, 4, right? That is a size of 5 because we have 1, 2, 3, 4, 5 elements there. So we got to make sure I is equal to all of these values. And A, well, we do not have a 0, so that's not right. So B, we start at 0, then we go to 1, 2, 3, 4, 5, because it's less than or equal to 5, and then we go to 6, but that does not work. But if we see here, we're going outside the bounds of the array, so we're actually going to run into issues. So this is too many. So that's not correct. What about C? C, we start at 0, then we go to 1, 2, 3, 4, since we're including 4, then we stop because 5 is now bigger than 4. And that's exactly the range we are looking for, as those are all the indices of this array of size 5. So this is our correct answer. So C is correct. Moving on to question number 29. Which of the following is a valid use of a fixed length array X of size 5 in the C language? So it's saying, is this the correct way to display all the values in an array? And it's basically just saying print, and then we print this variable X, which is our array. And this most certainly is not how you're going to print an array. This will just print the address of the array, because if you remember, X is actually an address, because the address points to the beginning of the array. So if you just print X, then you're actually printing the address. If you actually want to properly print this, you would have to use like a for loop. So you'd have to do something like this. So for I equals that. In this case, our size is 5. So less than 5, and then you would do this printf %d x at I. So that would be this is the correct way to print. So that's the correct way to print. So A is in fact not the correct answer because that's not printing what we want it to. B, copy all values from array X into array Y of the same size. So while this kind of may seem like it works, this is actually not correct, because what this is doing is now they're sharing memory locations. So anytime you update something in Y, it'll update it in X. And anytime you update something in X, it'll update in Y. So it's not a copy of each other, they're more just linked to the exact same array. If you were wanting to have them properly copy it over, one way to do it would be, so say we have our new Y, which we don't declare as anything, of size 5. I think that's the correct way to do it. And then the best way to do it is you would say Y at I equals X at I, because now we're just copying the value at every single point in the array over to the one in Y. So that would be, this is the right way to copy X to Y. Sorry, my handwriting got a little messy there. All right, C, add a new element to the end of the array X5 equals 0. This is not quite right, as if you remember size 5, well, that means we have indexes 0, 1, 2, 3, 4. So if we do X5, 5 is outside the bounds of our array. So we're no longer in our array anymore. So this is incorrect. Instead, what you should do if you want to add something to the end of the array is do X4 equals 0. And if you're trying to add an entirely new element to the array, well, you can't do that with a fixed length array. That is a much more complicated topic, which will be discussed later. So that means D, none of the above, is everyone's favorite answer, and it is the answer for this question. All right, number 30, which of the following statements regarding arrays in the C language is false? Values in an array are stored consecutively in the memory of a computer. This is true, so it's not a correct answer, as in the computer, basically you just have, like, say this is our address of the array named X, and it's length like 2 or something. So then X, this is technically X of 0, then X of 1, if this is an integer, I think it's 4 bytes, 8 bytes maybe, 4 bytes probably, I think it's 4 bytes. So then it'd be at 349, and then X2 would be at, I guess it was a size 3, and then this would be at 353. So the semantics of that are not important, but basically you just need to know that they are stored consecutively in the memory of the computer, so A is true. B, when used throughout a program, an array's name represents both its starting address and its size. So part of that question is true. This is true. It does represent its starting address, like we mentioned here. It points to the where in memory it starts, but it has no indication of its size. The user must keep track of what the size is. So it does not keep track of the size, which does in fact make this false, which makes it the correct answer. We'll check C just to be safe. All elements of a given array share the same data type. This is true. Unlike some languages, you cannot mismatch data types. So if you have the first value is an integer, all the values have to be integers. The first value is a character, all of them have to be characters. So be sure you keep that in mind. So, sorry, that means B is our correct answer. All right, question number 31, which of the following is not a valid function declaration for the function UDF on line number 4? Okay, void UDF int y is 5. So this one, we'll get back to that one first. Let's look at C first. This is probably one of the most common ways to do it, and this is a perfectly legal way to define a function, as we declare all we need is its type, and we do declare its type here, as that is the type. It's pretty much just a carbon copy of this, just without the variable name, as we do not need the variable name. This next one is again a copy of this. In this case, it's a complete carbon copy, including the variable name. So we have the type and var name, which is completely legal. You can use the type, and you can also use the variable name. And then finally, this one is the same, but now we actually declare what the size of it is, or something. No, the syntax is very odd, but this is still perfectly legal, as I think now we're basically just declaring the size, name, and the type, all of which are allowed. Although that's not actually, yeah, that's not quite what the size is. But if you were to run this in your C code, it would work. So that would make this D none of the above. I've never actually seen someone use the A way to write something, but apparently that is allowed, so keep that in mind. All right, number 32. Which of the following is the correct way to call the UDF with the array X as the only argument on line 8? So problem 32, now we're looking here is how do we actually call this array, or this function? So if you see here, we're passing in an array. So we need to make sure we pass in a memory address, not an integer value. And right away, that means this one is wrong, as this is passing an integer value, right? Because when we do x of 5, we're dereferencing it, and we're getting the value at the index 5. So we'd be passing in, just kidding, we'd be passing in this last value here. We'd be passing in 1, not the address, so that's wrong. Same goes for this. This would actually, I'll give you a second to think. What do you think this would pass in? It is an integer value. What integer value would it be? So I'm pretty sure this would pass in the first index. So in this case, it would pass in the 6 here, right? Because this is basically the same as saying x star, which is also equal to just saying x at 0. So it's just passing in x at 0, which again is just an integer value, and we need to be passing in an actual memory address. And so that makes C correct because we're actually passing in the address of the array. So then we can actually reference the array in this user-defined function down here, which makes C our correct answer. Question 33. Which of the following is the output generated by the code segment? Note that the correct function call and declaration have already been added. So if you remember the previous two questions, correct function call had not been added. In the actual code, or in the actual test, I don't think they actually show you what it is, but for it to run properly on boiler exams, I included it just so I didn't have people yelling at me that the code doesn't work properly. Anyways, we're just basically tracking what this code does exactly. So we have this array here, and if you remember right, my favorite thing to do, you got to make sure you check that we actually declare all of our values. So we have a 6 here, we have 1, 2, 3, 4, 5, 6. So we are good. So none of those will be initialized to 0. So we're good. So then we pass this into our UDF here, our user-defined function there at the bottom, and we're passing in the entire array. And while you may think, hey, we're not returning anything, why is this going to change at all? In fact, it will, because we're passing in the address of it. So technically, we're doing pass by address. So anytime you pass in an array, it is pass by address. So any changes we make down here are going to show up back in main. So if we pass in our array here, we have 6, 5, 4, 3, 2, 1. So let's look here. Our I, we start at I equals 1, and we're going up to less than 6. So basically, we're going to the end of the array, and we're incrementing by 1. The plus I versus I does not matter for a for loop. It does the same exact thing. So we look here, we're referencing I. So let's keep track of where our I is. So this is our I. So we're doing I, so y at I, which is 5, times y at I minus 1. So we're multiplying it times this previous one. And then we're storing that into y at I. So now this becomes 5 times 6, which is 30, right? And then we increase our I, and so now our I minus 1 is pointing here. But the new value at I minus 1 is 30. So now we do 4 times 30. So we get 120. Then we increment both of them again, since we're incrementing I. And we know this is no longer what that value is. So now we do 3 times 120. So we get 360. And then we increment I minus 1, not to there. This is now I minus 1. And then this is now I. And then we multiply 2 times 360, we get 720. Then finally we do 1 times 720, we get 720. So it's asking us x of 5 So if you remember, this gets passed back up because it's passed by address. So this x is going to have the exact, this is basically just going to be the array for x. Same values and everything. So x of 5, so 0, 1, 2, 3, oh, whoops, sorry. The 6 remains the same, so that's still the first value. So 0, 1, 2, 3, 4, 5. So it's going to be 720. So C is going to be our correct answer. All right, final question for this exam, question number 34. Given the following arrays declared in the local declaration section of a function, these int x of 5 and int y of 5 is equal to 1. What are the values of x of 0 and y of 1? Okay. I'm actually going to start with B and work my way through the different ones. You can start whichever one you want. But if we look at B here, it says both x0 and y1 are uninitialized. So actually what we're going to look at, so if you see here, we just declare the space for this array, but we never actually give it any values. And in this case, we actually do this little syntax here, and if you've probably seen this throughout the test. But basically what this does is it sets all the values in the array equal to something. So it sets the first value equal to 1, and if you notice, there's nothing else after it. But it's not going to just leave those empty. What it actually does is it initializes the rest of these values to 0. So that means this is going to be 1, 0, 0, 0. 0. One more 0 because it's size 5. So that's actually what this gets initialized to. And then this is technically just going to be null, or it's just going to be empty. It's not going to be declared to anything. So this is very trippy. You just need to make sure you know this. Anything that goes, if this value here, the number of these is less than the size, then the rest of them get initialized to 0. So if we look at A, I know I was going to say B, but I'll just start at A. X0 is uninitialized, so the value at 0 of x is uninitialized, which is true, since we never initialized any of x, and y1 is 0. y1 is this value here, and that is 0. So that probably means A is going to be a correct answer. But we'll look at B. So B, both x0, so x0 and y1 are uninitialized. We know all of y is initialized, so that's not true. That is true. X0 is uninitialized, but the y1 is initialized. So this is not correct. And then x0 is 0, and y1 is 1. Both of those are wrong actually. X0 is uninitialized as we talked about, and y1 is 0. So those are both wrong, and that makes A our correct answer. And so that is all for questions for this exam. Hopefully the video was helpful, and if you have any comments or suggestions or think I did something wrong, please leave them in the comments below, and I'll do my best to get to you. Thanks, and good luck on your exam.